K2-18b. No, it's not a name from a sci-fi saga. It's a real planet. A giant, 2.5 times the size of Earth. Suspended in the silence of space. Over 700 trillion miles from us. And remarkably, it may cradle the ingredients for life. Once again, the James Webb Space Telescope has turned the unknown into the scene. In a revelation that has stunned astronomers and ignited the imagination of stargazers, Webb has returned with its most detailed view yet, of the distant exoplanet known as K2-18b. Unlike past impressions, which were built on computer models and indirect clues, this is something new, an image born from light itself. The first real visual fingerprint of a planet we once only imagined. But this moment is more than a photograph. It's a leap in what we know, a push forward in our quest to understand worlds beyond our own. And a living testament to what happens when curiosity meets precision. A world revealed. The journey to K2-18b, located roughly 230 light-years away in the constellation Leo. K2-18b was first spotted using data from the Kepler Space Telescope. Astronomers had noticed a rhythmic dimming in its parent star's light, a hint that something large was crossing in front. This technique, called the transit method, revealed the planet's existence, but not its face. Not its atmosphere. Not its secrets. That is, until now. What the Webb telescope saw, Webb's new image, captured in infrared, doesn't look like a traditional photograph. There are no bright blues or visible continents. What we see instead is deeper, a thermal ghost glowing faintly with the energy of its star. A silhouette of heat. A shape rendered not in colors, but in gradients of warmth and molecular structure. This glowing orb, likely a mini-Neptune, based on its density, shows swirling gas layers, faint cloud formations, and subtle thermal shifts between its star-facing side and its eternal night. It's not just visually stunning. It's scientifically loaded. More than a picture. A scientific tapestry. Every pixel holds data, a thread in a vast cosmic fabric. From the glow alone, researchers can now build temperature maps, atmospheric profiles, weather models, and chemical inventories. This isn't just an image. It's a decoded message from a planet hundreds of trillions of miles away. Using two key instruments, the near-infrared camera, NIR-CAM, and the mid-infrared instrument, MIRI, Webb captured K2-18b during a planetary transit, peering through its atmosphere as starlight passed through the gases above. This technique, transmission spectroscopy, lets scientists read the planet's air, like a fingerprint in starlight. What we found inside the glow, early interpretations suggest a thick, hydrogen-rich atmosphere, with traces of water vapor, possibly methane, and even ammonia. These molecules may signal weather patterns, storms, winds, and chemical flows that drift across its skies. No, this isn't a planet made for humans. It's hot, it's dense, and it's wrapped in gas. But it's alive with activity. And in science, that's where the story begins. A new kind of observation. This image marks a new frontier in space science. Before now, exoplanets were known mostly through inference. Measurements, shadows, data points. But this? This is the real thing. Direct imaging, paired with spectroscopy and thermal analysis, all in one sweep. It's like going from hearing a distant drum to standing inside the orchestra. The shape of the future. The success of this mission reshapes how we teach, how we visualize, and how we dream. No longer are our visions of other planets mere artistic guesswork. Now, they're anchored in reality. A generation of students will grow up not imagining exoplanets, but seeing them, with data, detail, and dimension. And while K2-18b itself may not host life, it brings us closer to those that might. Closer to rocky worlds. Earth-sized or smaller. In calmer, cooler orbits. Webb's methods today will uncover Earth's mirror tomorrow. A planet, a mirror, a milestone. This achievement is not owned by any one nation. It is humanity's. Made possible by the collaboration of NASA, the European Space Agency, and the Canadian Space Agency. It took decades of work, tens of thousands of people, and a vision that defied gravity and doubt. What we now see in K2-18b isn't just a distant planet. It's a symbol of possibility, of exploration, of unity in the name of science. Philosophy in light to look at this world, 230 light-years away, not as a dot, not as a theory, but as a living, dynamic body, is to feel the scope of what it means to be small, yet capable of reaching the vast. Planets, we now know, are not rare. They're common. Every star, a potential solar system. Every solar system, a potential story. K2-18b is one such story, a chapter in the ever-growing book of cosmic discovery. Beyond the frameworks for years, we've labeled planets with broad names: Super-Earth, Mini-Neptune, Hot Jupiter. But K2-18b tells us these terms are just the beginning. Its atmosphere, its temperature, its behavior, all suggest diversity even within the same class. Now, our theories must evolve. And they will. Because K2-18b isn't the end. It's a signal. A preview of the billions more waiting in the dark. What comes next? Thanks to Webb, the blueprint is laid. Now, future telescopes, like the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope, can push further. Sharper. Deeper. This was just the first of many doors opening. In conclusion, to look at K2-18b is to gaze through a new kind of window. A window not into another solar system, but into a new era. An era where the unknown becomes seen. Where the distant becomes mapped. Where imagination and technology merge, to reveal the shape of the cosmos itself. If you found this journey inspiring, feel free to like and subscribe for more discoveries. Drop a comment below. What do you think we'll